So, fourth module, we'll see a DDoS case study and DDoS attack. So, please note that this is just a case study. There can be many more ways of performing DDoS. As shown in the figure, an anonymous hacker hosts a high orbit ion cannon DDoS attack tool on a web server uh, they own or on a compromised web server. So, here the attacker hosts the HOIC tool. HOIC, you will be seeing this tool in the iLabs also. This tool is used to um, um, fire packets at a very fast rate. And actually, we can control the rate also, but it will be tens of thousands of packet at a very almost intense instantly to the target machine. So the attacker will host this high orbit ion cannon on the web server or any other compromised web server. The hacker then advertises the high DDoS attack tool on social networking sites or search engines such as Twitter, Facebook, Google, and with a malicious download link. Users who desire to perform the DDoS attack may download the Hike DDoS attack tool by clicking on the malicious download link provided by the hacker. These users are termed as volunteers. See, after hosting the Hike tool, you will advertise in various social networking tools on Google. The volunteers will click on those pop-ups or links to download the Hike tool, and then these volunteers connect via an IRC channel to the anonymous hacker and awaits instruction to proceed further. So the attacker instructs the volunteers to flood the target web server, example PayPal, MasterCard, or Payback with multiple requests. Hackers advertise links for downloading botnets. The intention in doing so is to spread the botnet and increase the size of the attack network. Use of mobile devices as botnets for launching DDoS attacks. Malicious Android applications found in Google Play Store and as drive-by downloads are examples for infection methods. DDoS case study, a DDoS attack on GitHub. In January 2018, GitHub encountered a devastating volumetric DDoS attack, which made its service unavailable to its user for 4 minutes. This is the world's largest DDoS attack ever recorded. It was an amplification attack using a memcached based approach that peaked at 1.35 bits per second. Terabytes per second. The attack originated from over 1,000 different autonomous systems across tens of thousands of unique endpoints. The attack worked by abusing instances of memcache servers that are inadvertently accessible on the public internet with the UDP support enabled. The spoofing of IP address allowed the responses of memcache servers to be redirected to target at a different address and send more data toward the target than than needs to be sent by the unspoofed source. The vulnerability arising from this misconfiguration caused an amplification factor of up to 51,000, meaning that for each byte sent by the attacker, up to 51 kilobyte was sent towards the target. This large amplification factor caused a devastating inflow of 1.3 Tbps of data towards GitHub, interrupting its normal operations. GitHub response. GitHub personnel made the decision to move incoming traffic to Akamai. Akamai is a leading content delivery network, uh, CDN, service provider for media and software delivery and cloud security solutions. I'll repeat again. Akamai is the leading CDN service provider for media and software delivery and cloud security services. Uh, Routes reconverged in the next few minutes, and access control lists mitigated the attack at their border. Monitoring of transit bandwidth levels and the load balancer response codes indicated a full recovery at 1730 UTC. At 1734 UTC, routes to internet exchanges were withdrawn as a follow-up to shift an additional 40 Gbps away from GitHub's network.